Q Fever by Roxanne Turan, Caitlin Benally, and Jamie Young.
Q fever is caused by the Coxiella burnetii bacterium. The bacteria naturally infects animals such as goats, sheep, and cattle. Once in the host animal, it can be found and shed within birth products, urine, feces, and other such bodily fluids that are excreted from the animals. Those primarily at risk of becoming infected, or at least being exposed to the bacteria, are farming, veterinary, and animal husbandry workers, thus making it a zoonotic disease. Much like rickettsia, this organism invades and reproduces inside mammalian cells, which is why it can be found in such things as the placenta. Finally, the bacterium is classified as a potential biohazardous agent due to its resilient and highly communicable nature.
Since this disease is zoonotic, it can be transmitted through direct and indirect contact. When the infected animal gives birth, the bodily fluids from parturition are then spread around the area and infect everything it touches, which then can infect both humans and animals from the consumption of products or inhalation of the dried dust particles. Once infected, the individual will develop flu-like symptoms in 2 to 3 weeks, such as headaches, stomach aches, cramps, and other more severe symptoms like pneumonia, hepatitis, and neurological issues. Q fever is very difficult to get rid of due to its resilience to heat and many disinfectants. The most known sign of Q fever in animals is abortion storms in sheep and goats. This can lead to the infected animals to be infertile, have stillbirths, and abort every pregnancy. The organism is then shed through the fluids and dry and become aerosolized and transmittable to humans that work around these areas. It is also rarely fatal to the animal themselves.
The drastic culling of sheep and other remnants involved, who were also prevented from breeding, negatively impacted the lives of many in other non-health related ways. Those who faced the greatest economic hardships were not only the dairy and sheep farmers involved, but the greater community at large as well. While the families of these institutions had their means of income hindered, it in turn also impeded the economic stability of their consumers. Milk suppliers who depended on these businesses for their products suffered economic loss as well due to shortages.
To treat infected patients, they were prescribed 2 weeks of an antibody called doxycycline. People with life-threatening allergies to doxycycline were prescribed alternative antibiotics like moxifloxacin, clarithromycin, trimethoprim, sulfamethoxazole, or rifampin. Treatments were initiated as soon as Q fever was suspected and were later confirmed with serological tests. DNA PCR on whole blood or serum were used, or an indirect immunofluorescence antibody. To keep track of all confirmed cases, they were reported to the National Notifiable Disease Surveillance System. The system collects the data on how the diagnosis is made, if the patient was hospitalized or died, and any additional information.
Q fever posed a regular threat to the Netherlands from 2007 to 2010. At one point, there were over 2,300 human cases reported, with 20% of those cases resulting in hospitalization, 6 deaths despite receiving treatment during hospitalization, and a high mortality rate among the untreated. Specifically in 2010, the Netherlands experienced the worst of the outbreaks. Goats and sheep from 87 commercial dairy goat farms and 2 commercial sheep farms were culled from infected herds. Nearly 52,000 animals in total were euthanized, over 50,000 of which were pregnant goats or sheep. In addition to the culling, breeding among these flocks in general was greatly inhibited. Vaccines were made mandatory and a public education system was provided. Unfortunately, there was a vaccine shortage and thus the prevention plan wasn't fully carried out. For more information regarding Q fever or even Coxiella burnetii itself, be sure to check out the associated CDC information sites. Thanks for watching.